You ever wonder how Netflix just knows exactly what you want to watch next? Or how your Uber shows up in like minutes? Well, the answer to that magic is a really powerful platform called Databricks. And today, we're going to break down exactly how it works and why it is such a game changer for pretty much every modern company out there.
Okay, so here's our game plan. We're going to start with the huge data problem everyone's facing. Then we'll get into the magic trick behind it all, parallelism, and the supercharged engine that makes it run, called Spark. After that, we'll see how Databricks wrangles all that power into one place, and finally, why any of this actually matters right now.
All right, let's kick things off with the big problem, right? The core challenge. See, it's not just about having a ton of data anymore. That's old news. The real issue today is a full-blown crisis of complexity, and it's something almost every company you can think of is struggling with.
I mean, just think about the apps and services you use every single day. That spooky good recommendation on Netflix, the little car icon for your Uber moving in real time, those you might also like suggestions on Amazon. All of that, it's all powered by these massive, non-stop streams of data being crunched behind the scenes 24/7.
And the scale here, it's just mind-boggling. We're talking about petabytes. A petabyte is 1,000,000 gigabytes. That's what a company like Netflix chews through every single day, just to figure out what show you might like. I mean, your laptop's hard drive would just melt. Your average spreadsheet, forget about it. The old ways of doing things they're completely broken.
So, okay, if the old ways are totally busted, then what's the new way, right? How on earth do you handle that much information that fast without the whole system just collapsing? Well, the answer is actually a beautifully simple idea, a really profound concept in computing.
And that big aha moment, the foundational idea that makes all this possible, it's called parallelism. And really, it's all about working smarter, not just harder.
Okay, let me give you a really simple analogy. Imagine you're at a huge wedding, and you need to make 2,000 of these little fried breads called puris. If you have just one chef working alone, that's going to take, 4 hours? But what if you hire 4 chefs, and you tell each one, hey, you just make 500? They all work at the same time, in parallel, and boom! You've got all 2,000 puris in just 1 hour. It's just common sense, isn't it?
And that, right there, is the core idea in a nutshell. You take one giant task, you break it up into a bunch of smaller, manageable pieces, you give those pieces to different workers to do all at once, and then you just combine the results at the end. That is the fundamental principle behind all modern data processing. So this whole idea, it actually has a name. It's called distributed computing. Instead of having one massive, super expensive computer trying to do everything and getting totally overwhelmed, you use a whole army of regular computers. Those are our chefs, all working together like a single incredibly powerful system. This is, without a doubt, the bedrock of how we handle data today. Okay, so now we get the how, right? We get distributed computing. So let's talk about the actual engine that took this idea and made it explode in the world of big data. And that engine is Apache Spark.
So before Spark came along, the main player was a system called Hadoop. And Hadoop worked, but man was it slow. It was constantly writing data to the hard drive, reading it back, writing it again. Spark was a total revolution because it did all its work in the computer's memory, the super fast RAM. This made it up to 100 times faster. Seriously, 100x. And as a huge bonus, it was way, way easier for developers to actually use.
Let's go back to our wedding analogy. Think of Spark as the caterer. You, the developer, don't have to go and manage each individual chef. That'd be a nightmare. You just talk to the head caterer. You give them the recipe, that's your business logic, and they figure out all the messy details. That's exactly what Spark does. It handles the complexity.
But here's the thing. Even with a super powerful engine like Spark, setting it all up and managing it yourself, it can still be a huge headache. And that is where Databricks finally enters the picture.
Think of it this way. Trying to use open source Spark on your own is like planning that entire wedding by yourself. You've got to hire the caterer, the decorator, the photographer, the DJ. It's a ton of work. Databricks? Databricks is like hiring a professional event planner. You just show up and say, I need a wedding for 200 people, and they handle the rest. They make using Spark incredibly easy.
Now, the central idea that Databricks built is something they call the Lakehouse. And it's brilliant, really. It basically combines the best parts of 2 older concepts. You have the data lake, which is amazing for just dumping massive amounts of messy, raw data. And you have the data warehouse, which is great for super clean, structured, reliable data. The Lakehouse brings them together, so you get one single, unified place for all your data, all your analytics, and all your AI.
Okay, but just having all your data in one place is only half the battle, right? If it's a disorganized mess, it's useless. You need a system, a blueprint for organizing it. And Databricks pushes a pattern for this that is just beautifully simple and incredibly effective.
It's called the medallion architecture, and all it is a simple three-step process for taking your data from its raw, messy state and gradually cleaning and refining it until it's pure, high quality, and ready for action.
So here's how it works. You start with bronze. This is just the raw data dump, straight from the source. It's messy, it's chaotic. Then you move to the silver layer. Here, you start cleaning things up, you filter out the junk, you give it some structure. And finally, you get to gold. Your gold tables are the pristine, aggregated data that's perfect for business reports and feeding into your AI models. It's a really logical flow, from raw to refined to ready.
All right, so let's zoom out for a second and look at the big picture. We've talked about a lot of concepts. Why is a platform like Databricks such a huge deal? Why is it causing such a major shift in the entire industry?
So, at the end of the day, what does all this stuff, the parallelism, Spark, the Lakehouse, that medallion architecture, what does it all actually mean for a business? Well, what it all boils down to is this. Databricks gives you one single, unified platform where everyone can work together. Your data engineers, your data scientists, your AI specialists, they're all in the same place, working on the same data. It hides all that crazy complexity of distributed computing, it gives you a clear path to high-quality data, and it creates one single source of truth for everything, from looking at what happened yesterday to predicting what's going to happen tomorrow.
And that really leaves us with one final big question. In a world where data is just exploding everywhere, the companies that can unify their data strategy on a platform like this, well, they're gaining a massive, almost unfair advantage. So the real question isn't whether you should do this. In the age of AI, the real question is, can you possibly afford not to?